Welcome back, folks. Now, in the previous demo, I showed you guys UV-independent materials and illustrated that as a concept. Let's go ahead and put it together into practice by making a material that has multiple uses and kind of illustrates some of the elements of using the Unreal Engine's material system to its highest possible degree. Now, this will be your homework, but if you follow along, this should be easy to reproduce just for everyone. So what we're going to be covering in this is we're going to be making a material that is both performant and game ready and ignores, in general, not completely, but in general, ignores the functional UV surfaces of any particular object that you can apply it to. It's going to do its best using the Unreal projection system, but not necessarily using the world alignment in the way that I kind of illustrated in the previous demo. The world alignment tool is really good for working with certain elements. We can strip that down even further to create a material that doesn't inherently rely on any kind of UV direction. And one of the easiest materials to showcase that on, in particular, is glass. Glass inherently doesn't have a scale because glass is built off of realistic material properties such as Fresnelling and reflection and refraction and index of reflection. These are all scientific principles that have physical-based properties in the Unreal Engine. So let's go ahead and get started. And the reason why I don't have my video this time around is because I need to pop around in the material library here so we can. So unfortunately I can't have my video up, otherwise I'm going to block the details panel. But I'm going to go ahead and make something for you guys here. Go ahead and get started by making a new material. And we're going to call this M_UV free glass. And I'm going to save immediately. Remember, your autosave doesn't save anything unless it's already saved to the actual engine. Now I'm going to close the stuff that we had in here previously. Yes, I'll save that. That should be saved already. Close that, close that, close that, and close this. So we have our UV-free glass, and I'm going to go ahead and save my level since I made a new level. It's untitled. Oh no, file save as. So in the previous demo I showed projections. In this particular demo I'm going to show properties of, I'm going to show how to replicate physical properties of materials using basic scientific principles like IOR and using the utilities that are available inside of Unreal Engine. This is more of a proof of concept, but gives you guys a really good idea of how to kind of make your own shader when you need to make something like this. One of the most difficult things to produce well in games is glass. Because glass tends to be expensive. Glass tends to be ugly, or you have to make amends for what will work. Now, for those of you guys who played The Amazing Spider-Man, the newest game, their glass is amazing. We're not going to be making that because their glass is really amazing and very, very hard to produce or reproduce quickly. I'm still trying to figure out how they did it, but it's actually quite amazing in their particular engine. I'm going to showcase something similar, something that works, but this should give us a result that I think is going to be ideal and something that might even approach looking like glass, at least for a game. And if you can reproduce this, this is something that you can use consistently for glass, whatever you'd like in the future. So let's go ahead and start by, I'm just going to go ahead and place some elements. That's not what I wanted. I want to place some shapes. We'll get a cube, a sphere, a cylinder, and a cone, and we'll grab them all, move them up, and press the end key, or if you don't want to press the end key, you can go ahead and transform them, snap a line to the floor. Okay, let's see if I can scale them all without ruining them. It's not perfect, but whatever. Alright, close enough. Alright, this will be a good proof of concept for us. Let's double check our lights. Cool. Set my lights movable so we get a movable shadow without baking. Again, I don't have Lumen turned on because Lumen slows down my machine a lot and slows down these demos, but let's go ahead and get started. I'm going to go ahead and go back to my material here. I need to stop clicking that. I need to get more used to bumping that open. And I'm going to go ahead and grab my UV-free glass, and I'm going to get started here. So the first thing that I want to do is I want to create the basis for what refraction is supposed to look like. Now, for those of you who are less interested in creating materials and more interested in creating principles, or rather physical representations in math of what a material would look like, this is probably going to be the demo for you. I'm going to press C to make a comment box, and I'm going to call this refraction. Make this open. I'm just going to change the color to something that I can identify. We'll hit OK. And I'm going to go ahead and make some values here. So one of the values that you can use, or one of the utilities that you can use that's baked into Unreal, is actually Fresnel. If we hit Tab and type in the word Fresnel, it's not pronounced Fresnel, I used to pronounce it that way, Fresnel. This is the start of a utility that we can use, oh sorry, bumped the wrong thing, that contains an expression which talks about, yes, if you look at the word dot product, essentially what it is the elements of how a material like glass is going to work for us at the production level. Let's also go ahead and, once we've already called our utility, let's go ahead and change our blend mode to translucent. And that should be the only thing that we need to change. We should be more or less pretty straightforward. The last thing I want you guys to change is this is going to be a little bit more complex. We'll do some calculations based on realistic surfaces. Let's go ahead and change this value to surface translucency volume. Lighting will be calculated for a surface. Light is accumulated in a volume, so the result is blurry. Limited distance, but the per pixel cost is very low. Use this on translucent surfaces like glass and water. Only diffuse lighting is supported. The forward shading one is more or less the same thing, but very expensive and better looking. So if you want to experiment with that, go ahead and start with that. I'm going to go ahead and use the surface translucency volume. And that's more or less going to be set for us. Let's do a double check to make sure that I've got everything selected here. I do want to make sure that this is used with static lighting. Let's double check. Yeah, we'll enable that. You guys don't have to if you're using Lumen, but if you're not using Lumen, make sure that that's turned on. Let's go ahead and make sure everything else is on. As you can see, the refraction mode is already set to IOR. We don't have to worry about the refraction depth bias. We don't have to worry about that just yet. We'll have to add some value in at some point, but it's not going to be through there. Let's also double check to make sure that all of our settings are set. So what I'm doing here is I'm going through and make sure that the material is set to receive the math that I'm going to put into it. Yes, cast ray trace shadows. Yes, we'll apply fogging, surface translucency, no cloud fogging, no output velocity. We'll look at the shadow density scale. That looks good to me. We change the static lighting. That's fine. If you're using Lumen, don't enable that. If you are, enable it. Or excuse me, if you're using Lumen, disable it. If you are not using Lumen, enable it. I'm not using lumens, so this is enabled for me. This just goes to show where it's going to use. It just sets up certain flags to allow the math to work a little bit better. Okay, this looks set up for me. All right, I'm going to make a bunch of scalar parameters. You can go ahead and try to find it in here, but for me, the easiest way for me to produce a scalar, which is essentially just a constant but ready to accept a name, is press F and S plus left click very quickly. If you hold down S and press left click, you'll make a node. Just do it quickly. You'll get the hang of it. And I'm going to go ahead and create a few values here. We'll do Fresnel fall off. We'll do another scalar, index of refraction. I'll leave these as 0 values for now. I'm going to do a lerp. And then I'm going to do a constant. This constant is just to kind of reapply my math to make sure that we have a constant between not a value of 0 because 0 is turned off. We're going to go ahead and set this value to 1. And we'll plug this into the A mode here. And then the index of refraction will be set to a value that I think looks good in this particular system, or rather looks good in the game. And I'm just going to set that to 0.5. Now your index of refraction here would probably match at least what your value of your element is. Let me look that up real quick. Let me look that up. Come on, give me something. Let's see if I can use this appropriately. Doesn't want to load for some reason. So there's some charts that deal with index of refraction. Oh, there's some right there. And the transmissibility of various materials. These are physically correct, although not always physically correct for your values. We'll start at a 0.5, but we'll leave it alone for now because we're just going to approximate some of these values to get something that looks good in the engine. You can set your IOR to be more exact, but for my particular case, for my particular purposes, I'm just going to go ahead and put some values in here that are going to give us a fast result. Go ahead and set your Fresnel fall off to 10. Now you guys have seen me make glass before. Let me go ahead and see if that's still in here. It should be... this. In this particular case, I use a material expression and a reflection vector and a few little bits of math to get this to work, and that gave us this glass. If we notice that it's only actually reflecting the image that we applied in here when I used the HDR image. So this is what it's reflecting. That's not necessarily the best kind of glass for games, but it can give a really kind of overall good effect for most people. Alright, so what I'm going to do is I'm going to plug in the index of refraction into B here. I'm going to change the Fresnel fall off and unplug that into my exponent. So again, what we're doing here is we're multiplying whatever is happening in the lerp here by a factor of 10. And we are going to plug this into our alpha. So we've got a value between A and B where the exponent value is set for a value of 10. Our A value is set for 1. And our B value is set to 0.5. And what's going to happen here mathematically is it should give us something that looks similar to glass, but also give us some ability to control our opacity. So the first thing that we should do is we should plug our lerp into our refraction. Now, it's not going to give us anything right away, but we can see that there's something happening. Does everybody see that? Give that a moment. You can apply. It's not going to do anything right away because we haven't set up our opacity. But if we take our Fresnel, we can actually pipe that into our opacity, and that might give us a result right away. Usually I wait a few steps before I plug this in and test it. But let's go ahead and plug that in, and it should take a sec to kind of process. Alright, so it has processed. We see that there is something that looks like a ghostly image. It's not reflecting anything in the world, but let's go ahead and save that for now. I'm going to save everything in my content drawer as well, just in case. And we'll go back to our demo here. And I'm going to very quickly apply my UV-free glass. It's not going to look super great right away, but we can see that we will have a result right away. So you see that there is some amount of reflection, there is some amount of Fresneling going on. There is something that looks kind of like glass that's happening, and a lot of what is happening is based on these values right here. Changing these values does change the result. So let me go ahead and actually right-click my UV-free glass, the M version material, and I'm going to create a material instance. I'm going to rename that so that I have something that I can use. I know that's already exists. I'll do MI UV-free glass, and then I'll select everything. You can see that it's having trouble selecting transparent things. If you press the T button, that's the thing about Unreal. If you make something transparent and you can't select it, it's realistically because for some reason the engine does not like translucent selection. So if you open up your settings and you press the T button, you can see allow translucent selection. Go ahead and click that, or make sure that you press T or you check that on so you can select these elements. Otherwise, if T is off, you will not be able to select these things. So pressing T will allow you to select translucent selection. And then what we're going to do is we're going to apply the material instance of the UV-free glass, and we're going to open that up. I'm going to pop that out here, and then we're going to have a look-see to how that overall effect is going to change what is happening in the material here. So I'll turn on both these values, and let's see if I can get it to do something here. We'll go ahead and... Does everybody see kind of how by increasing the index of refraction, it gets really expensive once you start turning it up a lot. But you see kind of how that surface is changing and how the reflections in the world are affecting each other. Simultaneously, we can control our Fresnel fall off so that we can get something a little bit more less opaque, or we can go down the other way. See kind of how that result is affecting the way that the edges look. So we see kind of how that's working. Now the nice thing about it is the GPU doesn't actually have to work too hard to render this. So changing these settings and the index of refraction, so we can set it to like 1.5, something a little higher, gives us something that might resemble something a little closer to glass. But as you can see, it doesn't really have a surface. I don't know if anyone's looked at glass, but glass very definitely has a surface. Glass is not pure, right? This is a pure glass. Let's go ahead and continue working on this for a sec. Let's go ahead and I'm going to keep those values, but I'm going to minimize that, and we're going to set up some constants here. We'll do a little bit of math so that we can get this working. I'm going to go ahead and, at least for now, unplug both of these values so that I can continue working, because we need to pipe that math to different places. So this is very important. This is glass. If you do what I did, and you put this together, this will work as glass. This is no different from my demo that I showed, except we're using a Fresnel utility as opposed to just using and reflecting a world. We don't have to reflect a world. We can literally bend it by using the lensing available from that Fresnel. And of course the index of refraction. I'm going to go ahead and make another comment box by pressing C. And I'm going to set up some parameters. Now just follow along. Make a 1 constant. You want to drag it off from here. Make it constant 1. And then make 3 scalars. S and left click. 2, 3. Now I'm going to keep this fairly tight here. I'm going to instantiate my first scalar at a value of 1. Double check to make sure I set my Fresnel at the correct value here. That's fine. We'll set the first parameter here. We'll call this opacity. And I'm going to set this value to just a default value of 0.5. My roughness, or rather we need to set up a roughness value. That one will be set to 0. And then my specular value, the one that I said never almost gets used, hey, guess what? We're just going to crank that and set that value to 10. Alright, so let's go ahead and test out some more of this. And then after this, I'm going to stop kind of testing it out and I'm going to put it together and I'll show you guys kind of how it goes. So in this particular case, we want to be able to apply an opacity value, or rather control the opacity value with a parameter that is not just trying to manually control it or allowing it to be set by the index of refraction. Remember, we set this value in here and we didn't really have any way to control it. If we go ahead and pop this open, we see that we had a Fresnel fall off and we had an index of refraction, but glass isn't 100% clear. Glass is not pure. Glass has imperfections. If anyone here has an opportunity to look at an aquarium sideways, you'll see that the glass is somewhat bluish-greenish, right? Does anyone know why? Glass is bluish-greenish predominantly because there are impurities in the material. Iron glass is what makes the glass bluish-green. There are things like low iron glass where they use different mixtures of silica in order to make the glass look clear. You'll find that mixture under the name called starfire glass. We're not here to kind of discuss the chemistry behind making glass. But what we want to do is we want to make a UV-free glass that is going to work for, say, different scenarios in our game, and we can make material instances off of them. So what I want to do here is, now that I have my parameters set up, is I want to set up a few things. I want to be able to, 1, apply a frost to the glass, and 2, I want to be able to apply a color. Frost meaning that the glass has a rough surface, and 2, that the glass has a color, right? So I'm going to want to set those things up so that I do have the capacity to change not just the color, but to change the surface value. We'll go ahead and set this up. These parameters are going to be important to setting up the math for that. Let's go ahead and create a new comment box, and I'm going to go ahead and call this frosted glass surface. And I'm going to just kind of pick a color. I'll just grab an eyedropper and grab it from my desktop here. Cool. And we'll make 2 of these boxes. I did not mean to shrink it like that. There we go. Just move it over here. And let's try to keep these things somewhat organized. So I'm just going to make these relatively big so that I can add some math in there. And we'll call this frosted glass surface and frosted glass opacity. So this is going to be the actual surface, and this is going to be the opacity. Alright, So we need to actually go ahead and move our refraction over here because we're going to modify this pure surface with some amount of opacity. This is actually fairly straightforward, and we can use some of the parameters that we already have, which makes this easy. Let's go ahead and make another scalar. I know I keep dragging these from over here, but if you guys want to or are having trouble keeping up, it actually slows it down enough for you guys to catch up. So if you make a 1 constant and then convert it to a parameter, that is a scalar parameter. We'll call this frosted glass blur, and that's going to be set to 0. I don't want this glass to be frosty to begin with. I'm going to also go ahead and call a new utility called noise, and I'm going to open up the little caret here. Now, go ahead and you can play around and experiment with these values. I'm going to go ahead and put this on a node here, and let's see if we can start previewing this. This might give us a result, might not. Alright, does everybody see kind of how that looks super noisy? Let's go ahead and set this up. I'm going to go ahead and turn off turbulence. That's going to give us a slightly different result. And I'm just going to set the scale to something like 8. Cool, that's fine. Let's go ahead and reduce the levels. Let's see what that's going to do. So it gives us a tighter weave on the noise. And I'm just going to mess with some of the values. I'm going to set this to 50% output minimum. And the output maximum will be... That already looks pretty good. Let's see if I set that to 0.6. Now, it's not going to look like much now because it's a very fuzzy amount of value. But this is going to give us a relatively frosted looking effect that is very difficult to see because it looks like it's very fine, but if we look very closely at this noise, we can see that we can modulate it to something that works a little better. I think this is going to work okay. We can play around with the scale as we see fit in the future, but for now I'm just going to leave this alone. I think this will work fine for me. And we're going to go ahead and plug in the parameter to the filter width. And then this will allow us to change the amount of frost on the object. We could, in theory, put in a world alignment somewhere in here, but I'm not going to because it's not necessary, because this is just going to apply it unilaterally regardless of the UV of the element. Stop previewing this node. And we're going to do a little bit of multiplying. We want to take the dot product of our lerp here and left click drag it up to here, and we'll multiply it. I'm going to disconnect that because it's multiplying in the wrong value, so we're going to multiply this value of A times B. Now it's difficult to say what the numerical value is in here. It's hard to illustrate that as a concept, but the math linearly in this particular noise filter plus the math that is coming out of our linear interpolation, which has been converted for us through this lerp utility node, all this math, including the math from the Fresnel utility. This is all C++ for the record. Oh, not really, it's just basic math, but it's all coded through C++. We're going to do something called a parameter now, or rather a static switch parameter. What a static switch parameter is, it decides whether or not to pipe data along. It's basically a true or false statement. This is a Boolean value. So let's say we decide to actually use the frost. Right now this is set to 0. The parameter is driving whether or not this is going to be used. Frostiness. But the problem with that is the engine likes to decide, hey, I'm going to calculate 0 even though you say that it's 0. Wouldn't you think that it would make more sense to not calculate something that has a value of 0 rather than attempt to calculate something that doesn't have a value? That's not how Unreal works. Unreal calculates a 0 and it does eat some performance. So we need to be able to turn this effect on and off whenever we are going to use it and whenever we're not going to use it. Go ahead and right click the background, or if you're feeling spicy, tab, and type static switch parameter. And we're going to go ahead and call this frosted with a question mark. And let's go ahead and make 2 of these. Control W to make a copy. And put this over here so that we can control both of these. Alright, so what this is going to decide is if we turn on the frosted effect. As you can see, the default value is set to empty. This means false. It means that the glass is not going to be frosted, which means that all of these elements get bypassed. What this means is if this switch is set to true, meaning we turn on the frosted effect, and then we drag this to true, that means that the elements here are going to add whatever is going to happen this mathematically in here. And then we're going to need to input a parameter, it's going to add the noise, and it's going to multiply these 2 values together. If this is set to false, meaning that we don't want to use the frosted surface, it's going to bypass. Meaning that this stuff over here is not going to be calculated, and it's just going to pipe this data along. So if we turn on frosted, and we say, hey, we want to use frosted glass, it's going to turn these on. If we say no, and say no frosted glass today, please, it's going to ignore this data, and it's just going to bring this stuff into this node, and we'll pipe it through. I'm going to go ahead and pipe this into refraction for now. I'm going to change this to a cube. Alright. The next thing that I want to do is I want to also do the same thing that I did here, except I want to multiply the value of the glass's refraction. So let's go ahead and grab this pen and drag this over here, and we'll do a multiply. And I'm going to multiply whatever is mathematically in here. The sum of all of these values, I'm going to multiply this by whatever is in my opacity. So everything in here is multiplied by this value over here. So plug that into B. And then, since these 2 switches are the exact same, and they're named the same, and that's what makes this important, make sure that both of these are the same. If this is ever true, meaning that we are using the frosty surface, take this data, combine it with this data, take this data, pipe it into here, and ignore whatever opacity is set from this particular channel. We'll use the base opacity, meaning that whatever is happening in here and in here will control the opacity. If we turn off the frosted effect, meaning no frosty glass, let's plug that into false, we'll ignore this, we'll ignore this, we'll ignore all of this. Everything in here gets ignored, and then we'll just use this and this to control our opacity. Right? So let's go ahead and plug this into our opacity. And I'm going to hit apply. Now it's going to take a sec for it to come up. Alright. So it has come up. It's come back. We see that we have kind of similar values that we had before. Let's look at this on a sphere. We see that we have some result here. Cool. Now we'll test this out in a sec. We need to actually go ahead and add some color now. Our base color has been empty this whole time. Kind of annoying, right? So glass does have some color. At least when it comes to like games and whatnot, it usually helps to have some color, if not a full-on texture, right? Let's go ahead and now make another comment box. I'm going to glass color, we'll go ahead and color this like a blue. Okay. Let's go ahead and very quickly make two constants. We want a 4 constant because the math tends to work a little bit better. This is going to be a parameter. This is going to accept a texture. A 4 constant works better with a texture because a texture has R, G, B, and A. If you decide to have a color that is going to be based off of a texture and not necessarily off of math, this is what's going to make it work a little bit easier. I'll right-click that and convert that to parameter. And I'm just going to automatically open up the default value, and I'm just going to put ones in everything. 1, 1, 1, and we'll put 1 in the alpha. Cool. So what that does is it turns that on for any texture that you want to bring it in, or bring into the engine. Sorry. And we'll go ahead and call this glass color. And now, because I want to just do some dumb math, we'll go ahead and grab a 3 constant. A constant 3 vector does not have alpha information. That's okay. I just want some color. What color is that? I think there's like more blue in it. I'm looking at my aquarium right now from across the room to see what color that is. Yeah, that's could use a little more green, I think. That's fine. And we're going to use this as our default color. Now, because we don't want the math to actually decide whether or not, if we are using a color, if we're using a custom color, we want the engine to then actually do the math for calculating what our new color is supposed to look like. However, if we do not have a custom color and we're just accepting the default color, we're going to make sure that this stays off so this is not calculated. Okay? Some of you C++ students and programming students might actually understand what this means by using static parameters, switch parameters. The engine by default will calculate both. That has a performance cost. We only want to calculate both if we are using both. Otherwise, we want to use one or the other. Let's go ahead and create another static switch parameter. And we're going to call this glass color question mark. And if it's true, we'll take the RGB from this. And if it's false, we will just accept the default color. And I think what I'm going to do is I'm going to make the default color. Oh, wait, no. I want the default color to be false, meaning by default, this is the color that's going to come through. As you can see, the switch is default value is set to false. So our glass is going to always be this color unless we change it manually. All right? Now what I want to do is I'm going to go ahead and plug this value into my base color. Now, because this is getting really ugly, I'm going to add something called a reroute node. What this does is it allows me to do this. Just kind of move things so that I don't have to like cross any streams. Don't cross the streams. And I'm going to finish up some of the math here. Let's go ahead and plug in our, I'm going to save for now because I'm going to undo a few things here. I'm going to go ahead and plug in our value. So you see that our glass is already getting a color. That's kind of cool, right? Could be a little greener, I think. A little too green. But let's go ahead and finish some of our math here. Let's go ahead and plug this one value into metallic. Trust me on this, glass is just metallic. That's just how it is. It's when I know we talked about conductors and we talked about insulators. I know, but just trust me on this, glass is metallic. We already have our opacity being plugged in, that's fine. Let's go ahead and plug in our roughness. And let's go ahead and plug in our specularity. And then I'm going to save again. And I'm just going to wait. I'm just going to wait for this to do something. All right. So now let's go ahead and take a look. So everybody see kind of how that looks now? Now, if you don't want this super reflective surface, you can actually back off the value of the metalness, because that's what creates that kind of faked effect of the reflecting of the world. You can back that off a little bit to create something a little bit less intense. Let's go ahead and double check a few things here. So we've got our math, we've got our switches set and ready to work, we've got the color of our glass, we see that we're reflecting the world. I'm going to go ahead and save everything. And we'll go ahead and check. Oh, hey, look, it looks like everything is already being applied. Now you see kind of what happens when you apply a UV-free material to an object that has kind of, not jank, but kind of curious UVs, the way that the UVs work. This is just kind of a limitation of the hardware and the software relationship, so to speak. But as you can see, for a lot of these materials, this stuff works pretty well. So let's go ahead and play around with it a little bit. I'm going to save everything now that I have everything kind of built out. Cool. And we'll go ahead and check it out. So I'm going to go ahead and reset these values. And I'm going to minimize this to kind of shove this over here. And we'll kind of eyeball this through here. And I'll make this a little smaller so we can look at these values. So the cool thing is here, now that we've added some variety, we can definitely affect how the opacity of this element is working, for example. We can affect its overall surface roughness. And we see, oh, don't go over that. Don't go over value of 1 here because that doesn't do anything. Everybody see kind of how that result is? Cool. And of course, funnily enough, this gives the littlest effect. I think I have to crank it for it to show. But it won't show very much. This is really just mostly just to keep the math pretty clean and straightforward. This has a very limited effect on how everything looks. I would not mess with this value, but in some circumstances and in some lighting conditions, especially with how certain types of lighting conditions might work, it's always good to have this handle, even if you don't actually end up using it. Okay, so I'm going to make sure that we have a little bit of roughness here before I test out the next ones. Did I misspell opacity? I put an extra A in there. Apply. There we go. Let's go ahead and change the glass color. Cool. We'll give that a sec. And let's go ahead and change it to like a red. Or yellow. Something. Maybe a blue. I have to save before it applies in real time, unfortunately, because I made changes. There we go. We'll save this one as well. Cool. So you see that we can change the color. All this does is allow us to change this from true to false. So this activates it. This allows us to change whether or not it's true or false. And then we can change the color of the glass from here. Oops. Let's go ahead and disable that for now. See? You can disable it from here, or you can fully disable the option, and that leaves this set to true, but that's only for if it's defaulted. In this particular case, you see it goes back to our default color. Let's go ahead and turn on the frosted effect. Let's give that a sec. We see that we have like a frosted glass blur effect here. Let's see if we can get it to cooperate. Let's see if I can make that work. Might take a second to render here. Okay, I'm going to try to get really close to this so we can see kind of what's happening through it. Did everybody see that frosted glass effect here? Watch what happens as I move through the values here. This, in conjunction with the opacity, back to default. Everybody kind of see how that looks? Let's see if we can look at it through the sphere. It looks a little bit, I think, more obvious with the sphere. You can see how the index of refraction is like really throwing off the other glass. As we increase the blur value, by default, at a 0 value, we do get some amount of blur. So everybody see kind of how there's like some sketchiness in the background there? If we increase the blur, it cleans, or if we increase the value, we get a much cleaner glass. Unfortunately, if we don't go down, we don't get blurrier glass. This just kind of has to do with the way that our math is set up for the actual glass itself. Right here. Let's see if I invert this. If we can actually get the math to kind of clean up a little bit. Let me save. I usually just deal with it just being a little bit funky, but let's see if we can fix this. 1 minus is an inversion. So we'll do this, and then we'll do this. Let's see if it does something that we don't want it to do. We'll give that a sec. And I've only got like about an hour and a half of the class left, so I'm going to wrap this up pretty quickly. Let's hope that this compiles faster than normal. Come on, compile. There we go, compiled. It's definitely doing something, but it's not actually the intended result. I don't actually like that math. Shouldn't want to invert what's happening in there. Let's see what it's doing. Ooh, yeah, that's not what I want it to be doing. At this point, if you want to affect that a little bit stronger, you can go into the noise preview and see if we can get something that looks a little bit better. Let's see, 5. See if that changes that dramatically. 2. Let's go back to 1 and see if that gives us the result. So it's given us something a little bit noisier. Let's see if we have a higher output here. 0.5. Let's see. That's a 2. So I'm changing my output max here. That might be a little bit too noisy for what we want, but let's go ahead and hit save. You can play around with these values however you'd like. Let's go ahead and wait for it to compile. I'm going to reset my values while I still can. And we'll wait for this to compile. There we go. Now as we raise that value, it should clean up considerably more. The lower the value, basically what this value is light transference. If this value is 0, it's going to give us 100% of the blur because it's going to frost the screen for us. And if we add a little bit more roughness and a little bit less opacity, excuse me, a little more opacity, we see that we can really affect the way that these values are working for us. Default roughness. Remember, a roughness of 0 is the smoothest, cleanest surface that you could have, and a value of 1 is the dirtiest, roughest surface that you can have. This looks almost like a shower privacy screen almost. And again, we still have the ability to change things like our IOR. See kind of how that reflection is working. We have the ability to change our IOR. And we have, or excuse me, our Fresnel and our IOR, sorry. Keep cranking that up until bad things happen. And you can combine this effect. Oh, never go negative. That's kind of the scary thing. Do not go negative. And of course, all of this is easily tunable and controllable. It's going to take a sec for it to compile, so let's go ahead and actually, you know what? I can just turn that off from here. Or we can turn off all of these effects and get the default glass. As you can see, this performs fairly well. Let's go ahead and look at our GPU values. I'm going to go ahead and open this, open up my stats screen, advanced GPU. As you can see, it's barely even processing. Where is it? There it is. It's right there, translucent lighting. It barely registers. Translucency, there it is. It barely causes a performance hit. And that's the kind of performance that you want to see from a glass that you can use in a game. So if you want to go ahead and like continue to repeat these in like planes of glass and whatnot, it does work fairly well. The glass wouldn't be together like this. It'd be kind of separate. But then you can turn on all of the elements that you add before. Let's turn the roughness back. And you see that you have something that performs still fairly well. Where is it even? Translucency. It's still even more inexpensive than the geometry that's in the scene. It's just a little bit more expensive than just rendering the default lights. Not even the light rendering, but the elements for the lights itself. It's incredibly cheap to produce glass like this. Let's go ahead and turn that off now. All right. So I'm just going to make this your guys' homework. I would add some more to this, but in the interest of time, I'm not going to, mostly because there's some elements that you can add in order to make this a lot more spicy. Let me go ahead and bring this back to default. Cool, hey, that works. Save. Save. Save all. So there's a lot that can be changed about this in order to make this work a lot better, but you can see how you can hide a lot of the elements if you just change the properties of the way the glass is supposed to work. And this type of shader instruction is actually fairly easy and, again, performant, which is mostly what we care about. Does it look good enough? Does it perform well? I'm going to right-click this and stop previewing node. And I'm going to go ahead and shrink this down so that people can go ahead and see what this looks like. Just dock this here, dock this here, dock this here, dock this here, shrink that a little bit more. I'm going to bring everything in. I'll move this down here so that people can kind of follow it along. And let me actually tighten this up a little bit so if people want to look at the still of this to be able to do their homework tonight, they should be able to. Okay. So that there, more or less, explains a UV-free scenario, UV-free setup, and just pure shader math. This is just something that you end up having to do. Not everything has to be UV. There are some base materials that you can get away with just making inside of the engine, and glass and other elements like water happen to be one of them. However, with water, you have different elements like being able to create a particle emitter with Niagara. Don't use the particle emitter that is in UE4. That's going to be deprecated and removed. Niagara is in UE4 for those of you still using UE4. But this gives you a really good idea and a really good understanding of how you can utilize and leverage the UV-free power of just the basic math functions inside of Unreal to create more advanced materials that give you more power, more leeway, and more ability to create more things with only one material. I can now make a bunch of different material instances. Let's say if I wanted pink glass and blue glass, well, I just make two material instances instead of the one, and then I can just kind of modify all the glass that I need from one shader. All the glass in my entire game can be this one shader. That's it. This demo is just to showcase some of the more advanced elements that you can utilize in the Unreal Engine to create more advanced materials that don't necessarily rely on the output of an artist to create a texture or someone to create the material for you. You can build your own and you can build it from scratch. The important takeaway here is understanding that UVs do have limits, but when we do find those limits, we have to make decisions on whether or not we're going to open up a 3D modeling program and fix a UV, or can we create a surface that acknowledges and ignores the UV and aligns it with a projection like with a world align tool, or we can use a pure math function. We can use pure math functions to create a material that not only ignores the UVs, not necessarily that this ignores the UVs, but the surface properties do not depend on a UV-based system. This is not a 2D image. This is based entirely off of a surface property based on realistic mathematical exploitation and the usage of math to create a shader in a more traditional sense. Pure math, pure science, and pure understanding of the way that the material editor works. If this goes above and beyond your head, that's totally fine. This is more what technical art... Oh, just realized that. Sorry. This is more where you fall into technical art. Not sure why they call it technical art, because this isn't much art per se, but it's about being able to reproduce materials, surfaces, and objects utilizing what essentially amounts to programmatic function, and being able to manipulate the shader in such a way that gives you leverage when you are making a material that is not a traditional texture. All right. I will see you guys in the next one.